Hey guys, hey, it's Big Bertha. So today I'm just gonna talk to you about chemistry nomenclature. I got a few comments in my videos asking me to discuss like the chemicals or the ingredients in a lot of my products, like for example my olive oil eco styler gel, and I'm gonna do just that. So hopefully you can see it, but the molecule that I'm gonna be looking at today is not agua because we already know what that is, water. But I will be looking at triethanolamine. So triethanolamine. So now you're probably looking at this like, that's super confusing. Look at this long word. I don't know how to pronounce it. I got you. Break it down. That's all you have to do. Triethanolamine. What are these things? Well, first, let's look at this prefix. So in chemistry, we have different prefixes that goes with molecules in terms of nomenclature. To break down the prefix system, we have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. All right. Mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, deca is 10. Okay, so we know that based off of this prefix system, there's tri, 3 of. So tri equals 3. 3 of what? 3 of what? So now we're gonna go to the suffix. We're leaving that ethanol alone. There are some groups in chemistry you just have to memorize. This one is an amine group. So an amine is just a nitrogen atom that is in a covalent bonded relationship. Covalent just means sharing of electrons. So a covalently bonded relationship with other molecules. Now nitrogen has 5 valence electrons. If you look at the periodic table, you'll see a number on the very top. On top of nitrogen, you see 5. That means it has 5 valence electrons. In order for a molecule to be stable, it wants 8 valence electrons. So if you ever heard of the noble gases, they're very stable molecules. Why? Because it has 8 valence electrons. It doesn't seek any other valence electrons. Nitrogen has 5 and it's looking for 8. The easiest way that we can quench, in a way, nitrogen's thirst is to add a molecule that only has 1 valence electron. What molecule could that be? Hydrogen, right? So now, if you add 3 hydrogens, that nitrogen has 8 valence electrons. The way that we count valence electrons and covalently bonded molecules is just saying that they're sharing. So you just count it all together. 2, 4, 6, 8. Now that nitrogen is quenched. What's interesting enough though is that we see that there's 3 hydrogens. Okay, so if you think about this logically, you know that this amine wants 3 hydrogen or 3 molecules so that it can have its 8 valence electrons. And I'm just gonna put 8 electrons to remember, and wants 8 valence electrons. And now we see this tri also has 3, triethanol. I want you to know that this suffix ol just means, guess what? Alcohol. You guessed it, alcohol, right? The interesting thing about chemistry is that it's literally just a puzzle. It's a bunch of like prefix, suffix, you figure it out. And then some memorization. Okay, so this etha, right? This etha from ethanol. Let me just write the whole word. Etha means that it is an alkane. What is an alkane, you're asking? Let me erase all this. An alkane. What is an alkane? An alkane is literally just means it's carbons, because this is organic chemistry, and organic chemistry deals with carbons, right? It's just carbons that are single bonded. It's carbons that are single bonded. So let's go through the prefix system again with alkanes. So we have metha, etha, propa, tetra. No, buta. Buta, penta, hexa, hepta, octa, nona, deca. And I'm just gonna go through and write all the numbers. Metha, 1 carbon, etha, 2 carbon, propa, 3 carbon, buta, 4 carbon, penta, 5 carbon, hexa, 6 carbon, hepta, 7 carbon, octa, 8 carbons, nona, 9 carbons, deca, 10 carbons. Okay. So based off of this, we're looking at ethanol. We already know that we have triethanol amine. We have amine, right? Ethanol, right here. That means that there's 2 carbons. If you want me to break this down further, I can, but I'm just gonna do this quickly because I hear that little boy coming. So, we know that we have an ethanol. That means that there's 2 carbons connected to what? What's that suffix? Alcohol, which is OH, right? So the thing about carbon is that carbon has 4 valence electrons here, right? That one bond equals 2 electrons. So I'm just gonna put it here. And it's sharing. So here, right now, carbon has 2, 3, 4, 5. And it wants to have 8. Interestingly enough, hydrogen has a single bond. So as we see here, hydrogen has that single bond. You can just put single bond. So that carbon has 8. Because now if we count it all together, looking at this individual carbon and sharing the bonds, it has 2, 4, 6, 8. Look at this carbon, 2, 4, 6, 8, right? Because it's sharing the bonds. Okay. This is ethanol. Fun fact, when we drink alcohol, we don't drink methanol because that would be poisonous. We drink ethanol. This is ethanol. So we have triethanol amine. Putting it all together, because that's ethanol, that's an amine. The molecule that we're looking at, you can write this down to shorten it, and you could put C to H. How many H's? 1, 2, 3, 4, 5. 5 OH. C2H5OH. That's that same molecule. Because in chemistry, we don't want to write out all these carbons. You just shorthand it. So I'm going to write it the other way. So it's easier. But instead of having this hydrogen here, you can just bond that with the nitrogen. And then it becomes, because it's triethanol amine, C2, H5, OH. But I don't like how that looks. Because that's like assuming that the H is connected there. Oh, yeah. C2H5OH. Or another way that we write these is ETOH. So you know that's an ethanol. OH, ethanol, OH. So this is what the molecule looks like. Triethanolamine. It's an amine group that has 3 ethanols attached to it. So I'm gonna look it up on PubChem to see what the safety data sheet says about the molecule. Nobody calling me. But I hope you guys enjoyed it. I can go further in depth, but here's the thing about chemistry. As I always say, it is a vast field of study, and there's a lot of memorization, but then there's a lot of puzzle building. Okay? Hope you enjoy it.
Before you erase it, so how come you see OH and H5?
Yeah.
How come you just don't do H6? Oh.
Because if you did H6, that's a great question, Jorge. If you did H6, that would assume that that hydrogen is connected to the other carbons, whereas you have to separate it so that you know that's an alcohol. Because look, how could you tell the difference between C2H6? First of all, it also messes it up completely, because then if there's 6 hydrogens, then that means the molecule would actually be this. And there would be no reason to have that oxygen. So everything matters in terms of where you put the number. But that would create a whole different molecule. It separates it makes it easier for you to separate where that hydrogen is located on what molecule.
Okay. Valid.
Any other questions?
Like, what do you want people to know about these chemicals that they see in the back of?
I think a lot of people fear things that they don't know, and that's just life period, where you fear the unknown. But I'm showing you, like, literally, you look at this molecule and it might seem scary, but if you break it down into sections, you can figure it out easily and then look it up, and it's not scary at all. Just because you don't know how to pronounce something doesn't mean that it's bad for you.
Valid. Like that. But
No other questions you can ask. Hey, I might have an answer, I might not. I know who does. The good Lord.
The good Lord. Wow. Last question. So, what is this chemical today? Triethanolamine. We see everything it is, but is it good for people? Is it something you could eat?
So let me see. I tried ethanol. I'm pretty sure it's a preservative.
Preservative. Is that because of the ethanol?
Oh, no. Oh, man, you guys. At this point, you just gotta go to general chemistry. It's a buffer. And then it's surfactant. How do I even, describe what
a buffer is?
Yeah. And it says a surfactant. A surfactant is just compound that decreases the surface tension between 2 liquids, or a liquid and a gas, or a liquid and a solid. Don't really know what that is, but so in an easy way, yeah, a buffer is just an exchange between an acid and a base that keeps the pH consistent. That's the easiest way I can probably put it.
Okay, but pH, people in the hair community have to know pH is important.
Let me tell y'all something. I'm gonna keep this PG-13, but I think people should know. You should know about your pH, okay? If you're a woman, you should know about your pH. There's no reason for me to explain it.
Damn right. If y'all have
now you try to go in.
If y'all have comments in the if y'all have questions
about pH, maybe I can do something about buffers and pHs, but as a woman and as a man too, everyone should just know about pHs. Yeah, because men should know about their pH too, and they should know about the partner's pHs as well. You should know about your pH.
Acidic. All right.
But yeah, a buffer just keeps something in that pH, so it doesn't necessarily have a hand in the reaction, but it keeps it at a certain pH. All right, I'm done. So here I'm just going onto PubChem, my favorite website, to look up chemicals and typing in triethanolamine so I can figure out what the chemical is, what it's used for, and its safety data and hazard risk. Here I show you what the actual molecule looks like in 3D form. Next, I show you the description of triethanolamine, or T for short. And so far, it looks like it's just an irritant, but it's not toxic. Next, I'm just looking at the physical properties of the chemical. It's hygroscopic, which means that it takes moisture from the air. And then here I'm just looking at the drug medication information for the chemical. It's an alkalizing agent, which means it increases the pH of the gel. And then it's also a surfactant, which means that it increases the spreadability of the gel. Next, I show you the molecule's uses. Lastly, I show you the hazards that the molecule has. Again, like I said, it's just an eye irritant and a skin irritant, which honestly is okay in my book because it doesn't really irritate me. I just want to add two. I know I did the whole video about formaldehyde being in hair relaxers, which I still agree with what I said, but some of the chemicals that we use in lab, like for example, this one is a buffer. If you're using it in less than 1% of the solution, or less than like 10% of the solution, it's not that dangerous because it's pretty much being, what would you say? Like,
Its function is to interact with the other chemicals in the product.
yeah, but it's like, it's being used not necessarily in a major way where it's affecting you. Chemistry is not scary, it's just a puzzle. And you can learn that puzzle. I hope you enjoyed the video. Bye!